math session this evening, our first set of topics is real numbers and their properties. This is Professor Marjorie Thrall-Muller from Florida Southwestern State College. This lesson is for Liberal Arts Math 2, our MGF 1107 course. Textbook section 5.5. The union of the rational numbers and the irrational numbers is the real numbers. Subsets of the real numbers include natural counting numbers 1, 2, 3, and so on infinitely. Whole numbers starting with 0, 1, 2, 3. Both natural numbers and whole numbers do not include fractions or decimals. Integers also include negative numbers, but again do not include fractions or decimals. Rational numbers are any number that is or can be written as the ratio of two integers. So 0.45 can be written as 45 over 100. Negative 6 can be written as negative 12 over 2. 0 can be written as 0 over 5. 3 1/5 can be written as 16/5. 9 can be written as 27/3. 0.444 ... Any repeating and non-terminating decimal can be written as a fraction, such as 0.444 ... as 4/9. Irrational numbers is any number that cannot be written as the ratio of two integers, such as the square root of 7 or 0.4516 ... or pi. Properties of real numbers. Closure property of addition. When two real numbers are added together, their answer is a real number. Closure property of multiplication. When two real numbers are multiplied, their answer is a real number. Commutative property. Change the order. Addition is where we are adding the same two numbers, and we say 4 plus 6 is the same as 6 plus 4. Multiplication, 8 times 7 equals 7 times 8. Associative properties where we regroup. We do not change order, but we change what we're grouping together. And that works for addition as well as multiplication. Distributive properties where we multiply the outside number times every term inside the parentheses. Identitive property says if we add 0 to a number, we retain the identity of the number we started with. Identity property of multiplication is where we multiply by 1 and retain the identity of the number we started with. Inverse property is where we add a number and its opposite and get 0. Inverse property of multiplication is where we multiply a number by its reciprocal and we get 1. Imaginary numbers are not real numbers. I is equal to the square root of -1, and I squared by definition is equal to -1. Next set of topics, exponents and scientific notation. This is textbook section 5.6. 3 to the 4th means 3 written down 4 times and multiplied. The 4 is called an exponent or power. The 3 would be the base. Here are some exponent rules. Product rule, x to the 6th times x to the 3rd equals x to the 9th. When we have the same base, we add exponents. Quotient rule, when we are dividing with the same base, we subtract the exponents. So x to the 7th divided by x to the 3rd equals x to the 4th. Zero exponent rule, 4 to the 0 is equal to 1. Negative exponent rule, 4 to the -3 equals 1 over 4 to the 3rd. We take the reciprocal and change the sign of the exponent. Powers of 10. 10 raised to the 4th means a 1 with 4 zeros after it, or 10,000. 10 to the -3 means the 1 now is in the 3rd place to the right of the decimal point with zeros as placeholders. Scientific notation means the first number must be at least 1 and less than 10. Times 10 to an exponent, and the exponent for 10 must be an integer. For example, 6.4 times 10 to the 3rd is a number in scientific notation. Now, if we convert from scientific notation to decimal notation, and we take a look at a times 10 to the n, if the n is positive, we move the decimal point right n places. If the n is negative, we move the decimal point left n places. For example, 3.4 times 10 to the 5th becomes 340,000. 6.2 times 10 to the negative 3 becomes 0.0062. Converting from decimal notation to scientific notation. Determine A, the numerical factor. Move the decimal point in the given number to obtain a number greater than or equal to 1 and less than 10. Determine n, the exponent of 10. The absolute value of n is the number of places the decimal point was moved. The exponent n is positive if the given number, the number you started with, is greater than or equal to 10, and negative if the number is between 0 and 1. For example, 3,700 becomes 3.7 times 10 to the third. 0.014 becomes 1.4 times 10 to the negative 2. Here's some examples with scientific notation and multiplying. If we go 4 times 10 to the third times 2 times 10 to the 6, we multiply the number factors 4 times 2 to give us 8, and we multiply the powers of 10 to give us 10 to the 9th. Remember, we add the exponents with the same base. Division. If we have 6.2 times 10 to the 7th divided by 2 times 10 to the third, we group the numbers 6 divided by 2 and get 3, and then we divide the powers of 10. 10 to the 7th divided by 10 to the third, we subtract the exponents and get 10 to the 4th. Next section, arithmetic and geometric sequences. Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, ... The first two terms are 1, and every term thereafter is the sum of the two preceding terms. A sequence is a list of numbers that are related to each other by a rule. Terms are the numbers in the sequence. An arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a common difference called d. General term of an arithmetic sequence is a sub n equals a sub 1 plus parentheses n minus 1 times d, where a sub n is the nth term of the geometric sequence, and a sub 1 is the first term of the arithmetic sequence. Geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant called the common ratio, r. A sub n equals a sub 1 times r raised to the n minus 1 power, where a sub n is the nth term of the geometric sequence. A sub 1 is the first term of the geometric sequence. If you have any questions, please don't hesitate to contact Professor Marjorie Thrall-Moeller, and she will be glad to assist you. Thank you so much.